Boom. Hello and welcome back to Statistics1. Chapter 3, descriptive measures. And we are going to take a look at the measures of a center in the first. We have mean, median, mode. And let's see what each one of those is and how they're significant. So we start with the definition of a mean. Mean as an average, not mean as an evil, right? So mean as an average. The mean of a data set is the sum of observations divided by the number of observations. So the mean of the data set is the sum of all observations divided by the number of observations. So we can talk about average height, average shoe size, average weight, average age. We can also talk about average grade on the exam, which is usually useless because if average is, let's say, 78, that really doesn't describe whoever scored 38 or something, or 100, right? 107 possible. So we can't use mean for everything. Your exam grades are using something that it's called a weighted mean, because your assignments for this class, which is exam 1, 2, 3, homework, and project, they all have different weights, so they're not equally weighted. This definition of a mean is when you weigh equally. So say you have height data let's go in inches. So 78 63, 72. This is like a basketball thing. I don't know. Whatever. 74 and 77. All right. 5 players, right? So there's a team. And to find the average height of the entire team, you simply add all the heights and divide by 5, because there are 5 observations, 5 players. So it'll be 78 plus 63 plus 72 plus 74 plus 77 divided by 5. So what do we have? That's 140. So 78 and 78 will be 150 plus 140 plus, I didn't use 74 anywhere, divided by 5. You can use calculator to add all this at once, so that 290, 364, I think, divided by 5, which is 72.8. So about 73 inches, it would be the average. So if this is the height data, we would say that the average height, x bar, is 72.8 inches. That will be the average height. So you simply add all of the values and you divide by the number of observations. And for our example with grades, as I said, when I take a look at the average exam grade for all of the students, let's say exam 1, it's simply add all of the numbers, divide by how many of you decided to show up and take the exam. And then we have, so that will be the average. But then you have to be careful, as I said, because on the syllabus, when you take a look at exam 1, exam 2, exam 3, they all have different weight. So that's a weighted average, and we'll talk about that later in a course. So the next one is the median of the data set. So median is the middle entry of the data set when you have the data organized in increasing order. So you have to organize your data first, and then you just go to the physical middle of the data set and you pick that number. If there is no number in the middle, then you average the two numbers around the middle. It's very, very simple. So median is the middle data point in the increasing. I'm trying to see how you're gonna phrase this. So median is the middle data point of the, let's go with it, of the organized data set. That should be organized so that data points increase. So now if I want to come up with the data set for our basketball players from earlier, we had 78, 63, 72, 63, 72, 74, and 77. So the first thing is to organize data in the increasing order. So 63 goes first. Then we have 72, then we have 74, then we have 77, and then we have 78. And now pick the middle. Pick the middle number or data point, whatever. In our case, that's going to be equal to 74. That's the median, that's the entry. Now, sometimes data has even number of data points, in which case median is the average of two middle point data points. So say your data is 6, 13, 19, 21, 36, and 38. You see n equals to 6, right? 6 data points. So you don't have the middle entry, but you have this 2. So you would say 19 plus 21 divided by 2, which gives you 20. So median equals 20. As you can see, 20 is not the part of the data set, but since we have even number, we have to average the two in the middle. So 19 plus 21 is 40, divided by 2 is 20, and the median of this data set is 20. So when you have odd number of entries, you will pick the physical middle, and you're done. It's very simple. And if you have even number, you would always have to do the average of the middle two. So those are these. And now let's go back to our example from before to understand the difference between median and the mean. And why are we bothering with the different types of measure of a center? So I did mention a neighborhood earlier where you have a number of houses, and all of those houses are roughly in the same price range. So say each one of these houses is around 300,000, let's say. So each one of these houses about $300,000. So that means that the median and the mean roughly about 300K, right? So now what's going to happen is we are going to pick one house that wins the lottery. Wins the lottery $250 million. And what does this person do? Instead of moving out, decides to replace the $300,000 house with a castle. Spends, let's say, $5 million. It's okay, you know, like 20 rooms, 5-car garage, and indoor pool, and the rocket launch site next to the house. It's private space program. Yeah. Like that's what I would go. So if that happens, then what we have is 1, 2, 3, 4, 5, 6, 7. We would have 8 of these houses that remain the same, and then we get a castle. Maybe I should put these towers and stuff, right? So we know it's a castle, right? A little flag. There we go, perfect. Gotta put the wall up there. Excellent. The window for the princess over here. Good. And these windows right there. And we need that big door that lowers down over the stream. There should be some kind of dragon inside and stuff like that. You know, standard castle, $5 million. So now what do we have? You see that? Would you agree that between the two examples, median does not change? Right? So now, in this, right, this is 5 million. And these houses here are still 300,000 range. So median stays the same. Because if these two averaged earlier as a middle point, now you're going to have the same two houses average for the middle point. The same houses average, same two houses would average. So median doesn't change. But the mean changes a lot. So median stays the same because same two houses are, because we have 8 data points. So the same two houses are averaged get the mean, the median. And here in blood, the mean is changed. And this is why we are going to talk about outliers. Look what happens now. To find the mean, right? So for mean, add all, divide by the number of houses. So we know that we have 7 times 300,000, and then you have single $5 million house divided by 8 houses. Well, now it's, well, thank you very much. Now it's 8. Because we need to have 7 on a castle, right? Used to have 8. All right, then we'll add the house back. It's so easy over here, and let's just change this to 8. But then this doesn't work. So what's worse now? Median stays the same because the same house is in the middle. Because the same house is in the middle. Great, we don't even have to average now. Perfect. Now the median, so the median stays the same, the mean is changed. Boom. So we have 8 houses that are around 300,000, and we have one out of $5 million. So 8 times 300,000, that's 2.4 mil. Plus 5 million divided by 9. That's what you want. So now that's 7.4 million divided by 9. So our mean used to be 300, right? And now if you look at the mean, no, it's supposed to be 800,000, not 8 million. There we go, much better. So now if you look at the mean, it's 500,000 more because of that one house that was changed. So earlier, your mean and median were both the same. Mean was 300,000, median was 300,000 because the middle house was about 300,000. As I said, one of these houses wins the lottery, and instead of moving out, they decide to build a $5 million castle and stay in the same neighborhood. Median doesn't change because you still have these 8 houses here to have the same price tag as before at 300K. And one of those houses now is $5 million. So now you still go into the middle one and you look at its value, right? It's 300,000 and that's the median, so median doesn't change. But the mean does change because now instead of adding 300,000, you have to factor in 5 million. So when you calculate the mean, which is add all of the values, so if each one of these is 300,000, that's 300,000 times 8, plus 5 million, and then this is the sum of all of the prices, divided by how many houses you have, which is 9, And this is my 3 times 8 is 24, so we have 2.4 million for those 5 houses, for those 8 houses, plus 5 million for the castle that we have over there now. 7.4 divided by 9 is 800,000. So we see that the mean now changes, and this is why we talked about the outlier. You guys asked in the class about outliers. Well, clearly this house is the outlier, because it really changes the average, and the new average, the new mean, is not representative of the neighborhood at all, which is why we have to disqualify the castle from the calculation, right? And we would actually label it as what we call outlier. We are going to actually have exact calculation that tells us where the cutoff point is, and any data point above or any data point below, right? Upper and lower limits. That's coming up very soon. So we'll be able to spot outliers quickly, to calculate where those outliers are and kick them out. Right now we can see that this is an outlier, so, right? That's pretty much what it is. The next measure we are learning is called the mode. And that's the final measure. So mode is the data entry with the highest frequency. Mode is the data value with the highest frequency. If no value occurs more than once, then the data set has no mode. So let's make up a data set. Three 400, 380, 400, 600, 610, 340, 400, 510, 500, 300, and I don't know, 520, whatever. So these are 12 data points, right? N equals 12 data points. And we look for the value that repeats. If we have multiple values, then we look for the one that repeats most number of times. So how many 300s do we have? We have 2 300s. How many 400s do we have? We have 3. How many 380s? Only 1. I'm not gonna check that one at all. How about 600s? 1, 610, 1, 340, 1, 5. They all others are 1s. So here's our mode, 400. More is the 400 because it shows up 3 times, right? Frequency equals to 3 for 400. Now I'll write here, because we can have a multimodal data set. So if you have two values or 3 or 10 values that are showing up the same amount of time, each one of them would be also the mode. So you can have more than one mode in a data set. So we can have more than one data value as a mode. So 3, 8, 6, 7, 8, 3, 3, and 6, and 9, and 4, and 8, and 2, and 1, and 9, and 5, and another 5. There, whatever. So that's the data set. Consists of 16 numbers. Mode. So number 3 shows up 3 times. Number 8 shows up 3 times. Number 6 shows up twice. But we already have those that are 3 times each, so we don't even have to worry about 6s now. Number 7 shows up once, who cares? Number 9 twice, who cares? Number 1 once, number 4 once, and number 5 twice. So mode, we have 2, 3 and 8. So 2 mode in this case. So you are simply looking at the frequency. How many times that same number, in this case let's say 3, how many times it shows up in the data? Shows up 3 times. How about number 8? Shows up 3 times. How about number 6? Shows up twice. So clearly those are the winners, the ones that have more. So you can have 1 mode, you can have 2 modes, you can have infinitely many modes. If you recall anything from your algebra and pre-calculus and all those trigonometric functions and so on, you can draw a sine function wave which will go forever, and if you pick each peak, it will be a mode, and it will be actually infinitely long. So you can actually pick this up at, it's at pi over 2, and then 5 pi over 2, and then 9 pi over 2. So you can write it in a single as a pi over 2 plus 2n pi, and these are infinitely many of those, because this n goes 0, 1, 2, 3, 4, 5, 6, all the way to infinity. Keep adding these. So you can have data sets like this. So just pick up these points, create a data set. It's infinite data set, and it's going to have the infinitely many of these, and that will be the mode, right? Sorry, the value is 1 at that. So you would say value is 1, and then 0, negative 1, 1, 0, negative 1, 0, 1, and so on. So you can have multimodal data, 1, 2, 3, or more modes. Cool graphs to consider. If you remember our distributions, we had 3 distributions that we focused on. This one, and this one. So the first one is the right skewed. Then this is the bell shape, and the left skewed. So for this one, mode and median. So median equals mean. Now, median and mean. And on the other side, we have it reversed. Median and then mean. So our house example, is it right skewed or left skewed? Well, I need to be more specific. We have two examples. One, when before the lottery winnings, and one after. So before anyone won that lottery, you had 9 houses. So what distribution would the middle one? Yes, the middle one, exactly. And then when we have that $5 million castle added to the mix, the mean, yes, the mean is to the right of the median, so median always stays in the middle, guys. That's the physical center of the data. You would have to change more than 50% of data, right, for median to change. Does it make sense? Right? So that's that. We're going to introduce summation notation to ease up on our calculations, and the lecture is over. So summation notation. It's this sigma. So the meaning of sigma, let's say I goes from 1 to 6 of I, would simply be 1 plus 2 plus 3 plus 4 plus 5 plus 6, and that's it. That's what the summation means. Tells us where to start, where to end, and formula goes in there. So say you have summation of n goes from 3 to 8 of n squared minus 1. The first number you're using is 3, so this would be 3 squared minus 1. And then you have plus. The next number is 4, so 4 squared minus 1. Plus, the next number is 5 squared minus 1. The next one is 6 squared minus 1. And who went to 8? Plus 8 squared minus 1. And now you get to compute and add them all. So I hope you see the form in each one of these, and the value of n depends on the counter. Starts at 3, so first n is 3, so n is equal to 3 squared, and so on. So 3 squared is 9 minus 1 is 8, plus 15, plus 24, plus 35, plus 48, and plus 90. No, 8 squared is 64, 63. That's it. So now to add these, 15 and 35 makes 50. I have 48 and 8 and 4, that will be 50, 60, 80 plus, and I think we didn't use 63. $193, I hope. So summation notation is just a short way to put all the stuff together. Rather than listing everything, you can just use the summation notation. So we can start by, we can take our mean formula now and simply write it as this. So the top is the sum of all values, data values, and this over here is the size of the sample. It can be population too. We use capital N for population, lowercase for sample. So now this is the fancy way to write a formula for the mean. You can tattoo that, and that will be a conversation starter, right? They say, "Oh, what's your tattoo?" It's mathematical symbol for summation for mean, and then it opens up conversation, and there you go. Lifetime of happiness after that. Good. That's it. I hope you like the three measures of a center: mean, median, and mode. Very simple to obtain. You just need to learn which one is which and the way to obtain them. Remember, for median, to organize data in increasing order, because you are looking for the physical center of that data set for the location. Bye.